How does anything work ever? Because of the gods, said the ancients. Could be science, though, says Tails, casually beginning all of physics. Starting with the ancient physics, and then moving on to water's everything, and everything is actually water, said the same guy. I laugh at you, said the laughing philosopher Democritus. Everything isn't water. Everything is really small indivisible things, called atomos. Atomos means atoms in Greek. Check this out, said Pythagoras. Check this out, said Aristotle. By the way, stuff is where it is because I say so. Also, everything's made up of the 4 elements. Eureka! Screams the papa of mechanical engineering Archimedes, discovering buoyancy in his bathtub, also leverage mechanics, also area and volume maths, also catapults. But what else? Wait! Oh, wait! Look! A singularity. Made of gravity and energy compressed together. Bang! Rapid expansion! Says Hubble. Prove it. Alright. Well, just measure the cosmic microwave background radiation, aka the glow of the after effects of the Big Bang. Then it got colder. Ah! Screamed the unified forces as it split into gravity, electromagnetism, strong nuclear force, and finally the weak nuclear force. Oh, look! It's a hot old mess of quarks. No biggie, just the building blocks for everything, like protons and neutrons, which then became atomic nuclei, nucleosynthesis, if you will, making hydrogen, helium, and jumping forward about 400,000 years to the recombination era. Now light travels free. 13 billion years ago. Why does it transition like that? Whatever. Want to hang out? Said both helium and hydrogen to gravity, who quickly said yes, and smashed them into stars. Smash stars into hot galaxies. It's super hot, I mean really hot. And stars are cooking up some elements like carbon, oxygen, and iron, and some more. I wonder if we'll use those ever. Spoiler alert, we will. It makes up everything. Whew. Okay, where were we? Oh yeah, we were in the medieval Renaissance physics era thing. We're here. Anyway, eyes emanate rays, and that's clearly how we see, says Ptolemy. Vision is actually rays entering our eyes, says optics wizard Al-Hazin. I'm sure I said that correct. He nearly damn near invented a camera in 1000 AD, nearly damn it. Was the maker of the OG scientific method, and also, hey, this is wrong, by the way, says Copernicus. Crazy face, by the way. The sun is actually the center of our solar system. No, said the Catholic Church, but maybe, said the people. Anyway, now moving on to classical mechanics. I wish I could dance like that. It's championed by a bad mamma jamma named Galileo. Didn't say that right. Who said things that were doing what they're doing? That's inertia. And mashed out how stuff moves in space. That's perfect, said Galileo. Actually, squeaked Kepler, orbits are more of ellipses, not circle. What? Enter Isaac Newton. Read my Principia. Why this ball no move? That's the first law. Why does this ball does move? That's the second law, which is force equals mass times acceleration. You must have forced it. Why does this ball bounce? That's the third law, which means every action has an equal and opposite reaction. Newton is basically gravity. Gravity is why things do or don't do. Why orbit, they wonder. Gravity. Why apple fall, they wonder. Gravity. Why spring springy? Nope, it's actually proportional to the force applied, murmured Hook, while simultaneously discovering cells in a microscope. Check this out, says Huygens, giving us pendulum clocks. Huygens? Whatever. The Newton lookalike also said that light must travel in waves. How about fluids? It transmits pressures equally, said Pascal, while developing probability theory for stats. We're getting into the meat of it now, y'all. Doubt connecting champion James Maxwell, relativity and quantum science papa, has just related electricity, magnetism, and light, showing light to be an electromagnetic wave. Confirmed. Thomas Young's big old double slit experiment confirmed, literally changing how we see the universe. But porque when get electricity? Okay, I'm sorry I made that joke. Anyway, moving on. I'll use some of that electromagnetism, says Faraday. Here, have some stats, says Ludwig Boltzmann. Z's and names are cool, says Hermann von Helmholtz, laying the groundwork for the conservation of energy and thermodynamics and electrodynamics, and thermodynamics are pretty freaking hot, says Lord Kelvin, conceptualizing absolute zero and the heat death of the universe. Check this out, I can make sparks fly from a metal hoop, but at a distance, exclaimed Hertz in the 1800s, also getting his name worked into frequency measurements. Well, I can see through things, said the two-time Nobel winner, Madame Curie. discovering radioactivity, and then dying. Hey, what if atoms aren't the smallest things? What if they've got smaller things inside of them, said J.J. Thomson, finding electrons and the quantum revolution. We're on slide 185 of 340. Energy flows not like this, not all smooth, but in chunks like this, said Max Planck, and then put it into number form. Einstein time! Light is photons, that's Einstein. Space-time is the fabric of the universe, that's Einstein. Energy is just matter times light squared, aka E equals mc squared, that's Einstein. I bet electrons orbit in atoms, that's Einstein. No, wait, that was Niels Bohr. Shooting atoms at gold because there's a nucleus. I wonder if nuclear physics is ever going to be a thing. I'm uncertain. How fast is that particle and where is it, you ask? Can't say both answers, says Heisenberg, but I can tell you how damn near all things behave, because I'm Schrodinger. Or am I? I'm unsure. Particles are like waves, or particles are like a point. ¿Por qué no los dos? Why can't they be both? That gives me an idea, said Paul Dirac, smashing quantum mechanics and special relativity together to predict antimatter, aka particles that destroy regular matter. Gang gang pally, aka the Pauli exclusion principle, aka two electrons of one atom can't have all the same quantum numbers. What's a quantum number? Just properties of electrons. Enter legend Richard Feynman and particle physics in the mid-1900s. And my personal favorite, the Standard Model. And this, what's that? It shows us how electrons and photons exchange energy. He also made QEDs, which is quantum electric diagrams. What's that? It's how light and matter interact. How? Well, through temporary virtual photons, obviously. He was also a big teacher of the year, if you will. Need some energy? Good news! Fermi is here, and he just started nuclear physics, and he's making the first nuclear reactor. Remember quarks from earlier? Well, they're back, like they never even left. Let's go. We got Gel Man, and he says that makes up protons and neutrons, including them in the Standard Model, and they're orange. Talking about quarks still. Then we go on to Salam, Glashow, and Weinstein. I'm sure I'm killing all these names. Unified the electroweak forces together. Remember those? Remember how there were four forces? Well, they said that these bottom two here are two sides of the same coin. This was massive. What? Wait a second. How do we even have mass? The Higgs boson, of course, and also the Higgs field. Like how light is really made up of photons, the Higgs field traps everything but photons, slowing them down like it's all moving through honey, which is how they get their mass. What about that boson, bozo? That's just what was found at CERN Super Collider, where we slam particles together for fun and try and see that their special parts are made out of. The Higgs boson, like I mentioned earlier, was a ripple in a pond. It proved that the field existed, and into the model you go. Now it's 2015 and we just found gravitational waves, which is the same ripples, but now it's in space-time itself. My mic died. First, from Einstein's theory of relativity. These waves help us to see incredible cosmic events and we couldn't detect beforehand. What about the present and future? Galaxies are spinning, obviously, because they have matter, and our actual spin doesn't match what we would expect mathematically. What? That's because there's matter we can't yet detect, dark matter, if you will, and boom! The universe expands differently than predicted. Boom! Dark energy. Science is also looking for something called quantum gravity, which you would combine quantum mechanics with general relativity into the quantum theory of gravity, helping explain black holes and the Big Bang. What else? Let's see, we got string theory, which is actually guessed at that all matter is made of tiny vibrating strings, and it posits some versions suggesting a microverse. A multiverse, a bunch of Michaels, I guess. Anyway, but for now, we focus on fusion energy to solve our energy needs, smashing molecules together just like the sun does, but we're not as good at it. And on quantum computing front, we're tired of using only ones and zeros to do our stuff, so we actually made a computer that can use ones and zeros at the same time, processing information as fast as you hit the like and subscribe button. Please! Because that took forever and it's still kind of trash. There's so much I could talk about. Maybe I'll hit on it in the future. I like doing shorts more than longer videos, so I'll do a bunch on everything that I missed or made trashily in here. One day I'll go make this video, the whole thing, even better. But for now, I'm gonna go get a milkshake.